Okay okay good day guys, and welcome to Intellect Academy. So today we are going to talk about Ohm's Law, which is very important when it comes to electricity. So first of all, we are going to state what Ohm's Law says and give you the mathematical representation of Ohm's Law. Then we'll solve sample problem. That's it for today. So take note. Ohm's Law. So Ohm's Law states, provided the temperature remains constant, the potential difference, also known as PD or terminal voltage, in an electric circuit is directly proportional to what? The current flowing in the circuit. I come again. Ohm's law states that provided the temperature remains constant, the potential difference, also known as PD or terminal voltage, in an electrical circuit is directly proportional to what? The current flowing through that circuit. So now, mathematically, we say that the voltage flowing, which is also known as the PD or potential difference or terminal voltage, which is voltage, is directly proportional to what? The current flowing in that electric circuit, provided what? The temperature is constant. Provided the temperature remains constant, the PD or the voltage is directly proportional to what? The current flowing in that circuit. Now, I told you earlier, any case where we have a proportionality sign, for us to introduce an equality sign, we are going to introduce a constant. In this case now, when we remove this proportionality sign, we have that the voltage is equal to what? The current multiplied by the resistance. Now, this resistance is the constant. So we have V as what? The voltage. We have I as the current. And we have R as what? The resistance. Where this is measured in volts, this is measured in ampere. So we have this measured in and this is measured in ohms. So it's very easy for us to understand the concept of ohms, which says that provided the temperature remains constant, the voltage in the terminal voltage is directly proportional to what? The current flowing in the electric circuit. Now, let's talk about a case where we have internal resistance. Okay, now for an ideal case, for an ideal case, the EMF of a source voltage depends on what? The internal resistance of the source arrow, such that the terminal voltage is given by this expression. The terminal voltage is equal to what? The EMF minus the voltage drop. The internal resistance in a circuit will bring about a voltage drop. So we're having the terminal voltage V, we're having the EMF, which is in terms E, and we have the voltage drop. Now take note. Note that the voltage drop is equals to I multiplied by small arrow, where arrow is equals to what? The internal resistance. Where arrow is what? The internal resistance. So we have our terminal voltage V is equals to what? Our E, which is the EMF, minus I R. So take note that this is the expression for an ideal case where there is what? An internal resistance. So we said earlier that the EMF of the source of the terminal voltage or source voltage depends on what? The internal resistance of the source R, such that it is given by this expression. Now, first of all, we need to define what is internal resistance. Now, an internal resistance is the opposition to the flow of current offered by the cells and batteries, resulting in what? The generation of heat. We say that it is what? The opposition to the flow of current offered by the cells and batteries, which results in the generation of heat. Now let's draw a diagram of a circuit that illustrates the internal resistance. So we have a so this is the battery. So this is a circuit. So this is a circuit. So we are having the internal resistance and the total the big arrow resistance. We have a volt. So this is a typical example of a circuit that has the main resistance and what? The internal resistance. Where the current flows in this direction, I. So this is a circuit that has the internal resistance and the external resistance. Okay, now let's solve a question where you have, for example, now let's say we have a volt, which is an EMF of 12 volts, and we have a current of 100 ampere, and we have internal resistance of 0.1 ohms. Calculate the terminal voltage. Calculate the terminal voltage. If a cell battery has an EMF of 12 volts, current flowing through that circuit is 100 ampere. So we have RO, which is the internal resistance, as 0.1 ohms. We said that the internal voltage given by V is equals to what? The EMF minus the current multiplied by what? The internal resistance. So we have here V being equals to the EMF, which is 12, minus we have the current to be 100 multiplied by 0.1. So we have V, which is the internal terminal voltage, which is equals to 12 minus 100 multiplied by 0.1 is going to give us 10. So we have this as 10. 10 minus 2 is going to give us that the voltage is equals to 2 volts. So this is the value of the terminal voltage in a case where the EMF is 12 volts and the current is 100 ampere, and we have the internal resistance of 0.1. So thank you very much. In our next video, we're going to solve sample problem involving all what we have done so far.